Hello, I'm Theodore Tagle, and this is ENME 351 Lab 9 project. To give us some context for this lab, we have this crossing at Riggs Avenue and Baltimore and Annapolis Trail. Over the years, there have been a few deaths at this intersection because cars have blown right through this crossing and hit pedestrians. Although nothing has been put in place right now, there are some solutions being tossed around, and this project will address one of those solutions to prevent deaths. One idea is that as a person approaches a crosswalk, there will be a gate in place similar to a railroad crossing, and the gate will close, allowing for the person to cross safely. And then once the person has crossed, it'll open up again, allowing cars to pass through. A traffic light system could easily be implemented into this so that cars are given a red light and shown when to stop. However, this was not included in the project. To represent the gate, we have a servo, ultrasonic sensor, a person, and the representation and processing. If a person comes within 5 feet or 5 inches of the gate will close, and then they will be able to cross. And then they'll exit that 5-foot distance, and the gate will open back up after a 5-second delay, giving them adequate time to cross. But let's say a person approaches the gate, it closes, and then they cross. Then another person comes along and approaches within that 5 seconds. The gate is going to stay closed and reset the 5-second count so that they will also have adequate time to cross. The 5 seconds and 5 inches here are simply just used for demonstration and can easily be scaled up or perhaps scaled down if need be within the Arduino code. Now let's say, for whatever reason, that the ultrasonic sensor stops working and fails to detect someone coming close to the gate. There's also a manual override in this button here that will close the gate with a built-in 5-second delay and then open it after those 5 seconds. But also, in case that the ultrasonic sensor does magically start working again after the manual override is hit, if someone were to enter range within those 5 seconds, the gate will remain closed until that person crosses, waits 5 seconds, and then the gate will open again. The Arduino code here governs the actuation of the servo motor and the sensing of the ultrasonic sensor. To begin, we initialize the servo and ultrasonic sensor and the serial monitor at 96 baud. In the loop, we check whether a person is close to the gate or if the button has been pressed, and then enter the closing phase. If it has been triggered, the gate is closed, and then we begin to wait. As long as someone is within the 5 inches here, or the button is being pressed, the gate will remain closed. If someone exits the range and the button is not being pressed, then the 5-second count will start. However, if either of these sensors are triggered within the 5 seconds, then the gate will remain closed and restart the 5-second count. This is demonstrated here by the go-to statement in the middle of the second column. This will spit us out at the wait label back at the top of the loop if anything is triggered within the 5 seconds that we're waiting. If we successfully get through this 5 seconds and nothing has been triggered, then the position will be reset to an open position and the gate will be opened. The first of the functions that I've written to control the gate is open the gate, which simply uses the servo motor to open the gate to a position of 90 degrees. Then to close the gate, we simply have the inverse of the open gate to write the position to as 0 degrees. The third function simply converts the microseconds to inches that the ultrasonic sensor reads. And finally, to sense the ultrasonic sensor and get a reading in, we have another function from tutorialspoint.com that simply pings the ultrasonic sensor and then reads its input a while later. The if statement at the end of this function, if inches greater than 10, inches equals 10, is simply there so that there are no bugs with no one being in the way, such as if someone was, say, many feet away, the ultrasonic sensor would read, say, 400 inches. This is there so that there are no bugs in the code. For the processing code that represents the gate and the sensor, first we have to initialize our variables and bring in the image. Once we've done that, we get our serial port with the 9600 baud rate to make sure that we get our data into processing. When we begin our draw loop, we make sure that the serial port is reading the correct number of values, which is 3 in our case, with the delimiter of the tab. Once we've done that, we use the position to control how far the ellipse/gate has rotated, and we use the distance to see how close our person is to the gate. Thank you for taking the time to watch my Lab 9, and I hope you like the project that I've chosen as a solution for this dilemma. Thanks.